to another interesting section. Today we are going to be discussing about the concept of a relay. If you could remember vividly in our previous video, we talked about the concept of the contactor. The relay is similar to the contactor, but the difference here is that the relay is a miniature form of the contactor. By miniature, I mean the relay is a smaller version of the contactor. Now in relay we have different types of relay. But for our discussion today, we are going to be centered on the ice cube relay, which is also known as the electrical or electronic relay. Like I said, we have different types of relay. We have the timer relay, we have the overload relay, which we discussed in our previous video. We also have the solid state relay. So we have different types of relay. But for our discussion today, we are going to be centered on the ice cube relay. Like I said, we're going to be talking about the relay today. And under the type of relay, we're going to be talking about the ice cube, which is also known as electrical or electronic relay. Like I said initially, the relay is similar to the contactor. It's just that the relay is a miniature form of the contactor. So the relay can be defined as an electromechanical device that is used to make or to break an electrical circuit. Now we have, like I said, we're going to be talking about the ice cube relay. Here we have several ice cube or electrical relay. Here we have another one, various types. And here are the relay sockets that holds the relay. Like this particular ice cube relay, here is the socket. You can insert the relay inside the socket. We have several of them. Here is another type. Here is the socket. Here is the ice cube relay. You can insert. The socket is meant to hold the relay. We have, like I said, different versions. Here is one again. Here is the relay. Here is the socket. Insert this here. So now why it is called, I believe why it is called the ice cube relay is because it's a form of an ice, because of the transparent nature of it. As you can see, you can view the content, the internal content of the relay. So before we proceed to talk about the principle of operation of the relay, let's discuss about the parts of the relay. Now, one of the parts, like I said, is the relay socket. Here we have the relay that contains the ice cube relay as a system that contains several parts. If you can check closely, inside here, this orange color is the coil of the relay. If you still remember vividly when we discussed about the contactor, it has a coil which is known as the electromagnet. It has a moving part known as the armature, which is also referred to as the contacts. Now, the relay, like I said, has three major parts, which is the coil, contact, contact, and the contact we have the normally closed contact, we have the normally open contact, and we have the common contact. We're going to discuss all of that. Common contact and the relay socket. The relay socket is meant to hold the relay, and it is able to hold the relay by reason of the pins that we have here. The pins are inserted into the socket. Now, if you are familiar, or if you can visit our previous video on contactors, like I said, the relay is similar to the contactor. Now the coil of the relay is normally energized by either an AC or a DC source. One thing you need to understand is that the coil is separate from the contact, in the sense that there are certain relays in which the coil is being energized by a DC, but the contact can accommodate AC. But there are certain relays that both the coil and the contact are rated to be energized or to be able to hold an AC source. And there are other relays that both the coil and the contact are designed in such a way that they can accommodate only DC source. Very important to note. Now, talking about the principle of operation. First of all, let's have a close view of this ice cube relay so that we'll really appreciate what we're discussing. Let's have a close view of what I said. This is an ice cube relay. If you check closely, we have a symbol here. There's a symbol of the coil, and it is rated or has a specification of 250 volt AC. That is to say, the coil is meant to accommodate an AC source. You can see a symbol here. This is a symbol of the contact. The contact is designed to be able to hold up to 10 amps and also 250 volt AC. So here both the contact and the coil are meant to carry an AC supply. Okay, now if you take a close look, you can see here is the coil of the relay. Like I said, the part of the relay. If you watch closely, inside here are the contacts. Now what happens is that if the coil is energized, this part of the relay is pushed in. But first, when the coil is energized, what happens is that the coil is capable of producing an electric field when it is energized. So that electric field developed creates a magnetic force that pulls the contact, the normally open contact, pulls it to close. When the field is set, that's the electric field is set, there's a force created between these two coils here. So what happens is that if you check, there is a normally closed contact existing. That is when the coil is not yet energized. But as soon as it's energized and a field is created, the magnetic field is capable of pulling this common contact towards the normally open contact, making it close. So what happens is that what happens is that when the coil is energized, You can see, watch closely, you will discover that there's a contact that closes there. You can see a movement there. When the coil is energized, the normally open closes. When it is de-energized, it goes back to its original position. Now here are the pins. The pins here determine the number or the set of contacts you have. So these are the parts of the relay. Every relay has a similar orientation or path. So now we're going to look at the principle of operation. We're going to discuss it so that you have a better understanding. Here we have the diagram. But before we proceed, I'd like to bring to your attention that every relay has a circuit diagram of the contact. But what we saw on this relay, if we take a close look, we'll discover the contacts. You can see, take a close look, you can see number 1 here is a contact. 1 and 4 is normally closed. 1 and 3 is normally open. 6 and 5 normally closed. 6, 7 normally open. 11, 8 normally closed. 11, 9 normally open. And here you see the coil. Well, the coil is on pin 2 and pin 10. So it has a circuit diagram. Because when you're about to do the connection is actually done on the socket. The relay socket is the relay socket. If you check, it has a corresponding numbers. You can see 1, 6, 11, 10, 4, 3, 5, 7, 8, 9. So, like we said, from our relay here we have what is the position of the coil. If you check closely, the coil is on number 2 and 10. So when you're connecting it, 2 and 10 are the coil of the relay. Here we have 2 and 10. 2 and 10. So you connect your input to the coil at 2 and 10. You can see even A1 and A2 are written against it, showing that these are the coil. So from our diagram, we can know which position to do our connection. So 2 and 10 are the coil. From the diagram here also we saw 1 and 4 as a normally closed, 1 and 3 as a normally open. So if you want to make a connection on the relay socket, you have 1 and 4 as a normally closed, and you have 1 and 3 as a normally open. So 1 is the common contact, 4 is the normally closed contact, 3 is the normally open contact. So with this, let's talk a little about the principle of operation. So from our diagram here we have the coil represented by pin 2 and pin 10. And we have a set of contacts. Here we have number 1 as the common contact, 1 and 4 as the normally closed contact, 1 and 3 normally open contact, 6 and 5 normally closed, but 6 is the common. 5, when 6 and 5 are connected, this before the relay is energized, is known as the normally closed contact. 6, 7 normally open, 11, 8 here normally closed, 11, 9 normally open. So what happens here is that we say the core is energized by either DC or an AC source. But for my example here, where we're talking about this particular ice cube relay, the source here is a DC, it's an AC source, 250 volts. So when 250 volt is fed into this coil, because here we have 2 as our A1, then as our A2. So when we connect the supply here, this particular coil is energized. And when it is energized, it creates a magnetic field. Create a magnetic field in the contact, thereby making the normally closed contact to open. Normally closed contact open to close the normally open contact. So there is a movement from this point to this point, from this point to this point, from this point to this point. So when the coil is energized and the magnetic field is set up, that force of attraction pulls this common coil from this position of normally closed to this contact which is normally open. By so doing, the normally open becomes closed and the normally closed becomes open. The same thing happens here. The same thing happens here. So when we look at the practical aspect, we'll have a very good understanding. So what normally happens is that we'll have a connection here. Maybe you have a sensor. Let's say you have a sensor in which you want only a situation whereby the coil is energized for current to flow. So that sensor, you want to connect it on, for example, you connect it on 11 and 9. The sensor is connected in such a way, or you have a system in which you want it to be regulated when it senses a particular signal. So that particular system will be connected on 11 and 9. So when the sensor senses a signal and powers the coil, there is a shift from the normally closed to the normally open, thereby creating a pathway for current to operate the system. So to really have a vivid understanding, we are going to look at the practical section in our next video, and that will really help us. Thank you for watching. And you can visit our channel to watch other interesting aspects. Like I said, we have the concept of a contactor already discussed, so you have a very good understanding